afternoon. This is Paul Mann from the Pentagon. Good morning. It's a different time zone here than where you're at, but it's my high privilege and honor to participate with you on this 19th Annual Acquisition Research Symposium. So I'm going to lead us through some introductions and participation with three of my colleagues, Larri Fish, Ray Madachy, and Christian Thiessen, and we have three really excellent briefs to fill your morning and early afternoon with things about unmanned and making you think. A little context for me is I'm assigned presently as the co-director of the Unmanned Task Force. It's a cross-functional team here under the VCNO and ASNRDA, where we're trying to not only think about the requirements, but to buy things that we learn about as fast as possible and solve operationally relevant problems at a speed that, quite frankly, we've not typically been doing. So that's the context. I have a fantastic team of professionals of government and industry here working this cross-functional team. So this particular topic is of particular importance to me. As it turns out, at the same exact time, I'm assigned presently within the ASNRDA as the Department of Navy's Chief Systems Engineer. So standards, model-based systems engineering, technical authority, and modular open systems architectures, all of these are core disciplines and are foundational for delivering capability to the United States Navy beyond just ships, submarines, and airplanes. We need to generate and produce and sustain a competitive advantage against our adversaries. Many of you have read either the classified or unclassified National Defense Strategy. So I assure you the research today you're going to hear about is relevant to the protection of the citizens of the United States. So I'm actually delighted to be part of it. I've partnered often in my life, and people will say that seems like a strange affiliation, but the Government Accountability Office are true professionals, and they look at us objectively and with facts and data. Sometimes we don't like what we hear, but the truth is they're part of our team, and having effective oversight is really important, especially when we're trying to transform. Of course, we're always proud of our graduate students at the Naval Postgraduate School. Captain Christian Thiessen will represent that today, and Ray as well. But the bottom line is we don't have all the answers. We are supporting and sustaining the research investment because we actually know we don't have the answers. And we're hoping that in our learning together, we call it our campaign of learning, that we'll get to a better place for the United States. So that's my opening context. There's a lot of news going on. We don't really get to control what our enemies are doing. We didn't think we were going to be jumping through our grommets to get to EUCOM. And as you watch the news, there's a new theater that we're spending a lot of time trying to figure out how to support. Unmanned systems, as you might imagine, are going to be part of the lethality that we can offer our allies and use ourselves. So I'm going to pause there, and I'm going to take a deep breath, and I'm going to turn it over to Larri for our first round, and we're going to kind of go in this order. Larri Fish will go first, Ray Madachy will follow, and then Captain Christian Thiessen from the United States Marine Corps will wrap it up. We have a Q&A box at the bottom of your screen to pose questions. We're going to let the briefers brief all three sessions first, and then I'll come back on the net, and we'll get through as many questions as we have time for, up to and including when it stops 20 minutes after the hour. This concludes my opening invitation. Please tune in your listening. Go on mute if you're not actually the one briefing. And Larri, Ray and Christian, good luck. Over to you, Larry.
Thanks, Paul. I really appreciate those sentiments, and we enjoy working with the Navy very much. And I've worked with the Navy now for about 12 years, and the Navy is also full, obviously, of wonderful people who are competent acquisition professionals, and we do enjoy our interactions with the Navy very much. So I appreciate that. I will be briefing on the Navy's current 4 major uncrewed maritime system acquisitions: XLUUV, LDUUV, LUSV, MUSV. So the Navy envisions using uncrewed systems in its future fleet. We all know that, but how? And I think that we've seen a little bit of an evolution on that front. So at first, the Navy wanted to really target dull, dirty, and dangerous missions, kind of as a crawl, walk, run type of a scenario, trying to get robotic systems into the, not only the forward fleet, but also the rear fleet to help with maintenance or other tasks. And that's kind of evolved a little bit in our view, and I think the Navy has said that as well. And they're now emphasizing more lethality with these systems. And so they're looking for jobs that these systems can do, missions that these systems can accomplish while they're still young, let's say young in their technology. They're still moving along, but there are some missions that the Navy has identified that in the near future could be accomplished with near future technology. And obviously the vision would be that those would grow in complexity over time. But to do it, they need a digital, what we call the digital infrastructure. The Navy has called this enabling capabilities or core technologies. And I'm going to call it the digital infrastructure at all. We're all referring to sort of more or less the same thing at a high level. At a lower level, we view the digital infrastructure as the data, the people, the software, the modeling and simulation, the network space needed to make these assets run. And so how we view the digital infrastructure is, the infrastructure that takes in the data, organizes the data, analyzes the data, develops the algorithms, trains the algorithms using the data, tests the algorithms in a modeling and simulation environment, and then is able to push the algorithms out into the fleet. This is a critical part of these 4 systems, and as we'll talk about in a minute, we think this part is a little bit behind the rest of it. So as we said, Navy's approach is a work in progress. This chart shows more or less where, sort of where, I mean, at a very high level, where technology is now and sort of the leap over that white arch there to get into a whole different realm of technology that we think. And there's obviously a lot of middle ground in between there, but at a high level, that's kind of how we see it. And in looking at the 4 programs, we went to look at costs. We wanted to look at costs in particular. What's this going to cost? I think the big thing is that we view this as a big effort that's going to take a big coordinated push. And I think that the Navy's commitment, and Paul, you definitely have a different perspective on this, but the Navy's commitment to this has been a little bit straddling the line, and maybe not the full commitment that, then we can talk more about that as we go, but to make the full commitment of what these may be. And the prototyping, we can talk more about that too, but the prototyping, I think, allows some to toe in the water a little bit before making a commitment, but it may be that these just need a big commitment because this is a big effort. And then the second thing we looked at is the management of the uncrewed system programs, and we really looked at that together, as we'll talk about. And then lastly, we looked at the planning. So the first thing is the cost. The Navy had developed some costs, acquisition costs for the specific vessels, but has yet to really put a price tag on the digital infrastructure and the sustainment of the digital infrastructure and the vehicles, as well as other pieces of sustainment. And so that's kind of a big piece of this, because to understand the level of effort that the Navy needs to put forward, I think you really do have to understand the costs. And understanding costs is a critical piece not only in sort of assessing and understanding the uncrewed effort itself, but I think also to understand the affordability impact on the portfolio. And the Navy has some major affordability issues, even before inflation and supply chain and everything else going on in the larger economy, but also, you know, with Columbia and some of these other big acquisitions, it's a major issue for the Navy, and especially in the goal of reaching 355 ships. So, and it's interesting because depending on who you talk to in the Navy, and we talk to a wide ranging of folks, there's really a wide assortment of estimates as to what the digital infrastructure may ultimately cost. Anywhere from, you know, maybe $1 billion at most to 10, $20 billion. And I think looking at some of the effort and costs that commercial companies have put into getting data, organizing data, getting computer systems that can handle all that data, we think it's probably on the side of the bigger effort, but we don't know, and the Navy doesn't know. And so I think that's a critical piece, is to get that knowledge. And so that's more or less the cost piece. And then we looked at portfolio management. Well, we looked at the management of the uncrewed systems. And in the management of the uncrewed systems, we really took a portfolio approach idea and said, and looked at the uncrewed system and said, how is the Navy managing these as a portfolio, if at all? And a portfolio, I think the easiest way to think about managing a portfolio of acquisitions is really the same way you'd manage a portfolio of financial products and investments. You know, from the perspective of you want to assess risk across the portfolio. You want to, you know, which will allow you to take some risks on one end, but on the other end also have things that are maybe less risk, that are more of a guaranteed jump in capability, or you're not guarantee, but closer to a guarantee in jump in capability. And so to really balance across the portfolio, okay, what capabilities do I want? What risks am I willing to take? What costs, you know, and then you can assess that cost to risk to performance ratio. And that's the approach we took. And we found that the Navy has not quite coalesced around that approach yet, which we think would help. And then the other piece is, as if they had a portfolio leadership, which could, you know, and this is likely a non-bureaucratic function. So this is probably something that's outside the bureaucracy that, you know, a task, or, you know, and it might be something that in you know, Paul's unmanned task force is something that hadn't quite matured at the time we completed our report. And so maybe this is something where the unmanned task force comes into this role, and that would be wonderful from our perspective. But it doesn't provide also that internal champion. And I think that that's the piece where we think without the internal champion and without somebody articulating the vision of the digital infrastructure, that's the piece that I think is the hardest sell from a PPBE government funding perspective. And so that's where our concern lied primarily, is can we get people in the Navy on board to potentially attack this huge effort that we think is worthwhile, but getting them on board and understanding, okay, what is digital infrastructure? What does it mean? Why is it important? Why are we putting all this money toward it? Answering all those questions is really going to take what we view as an internal champion, likely the leader of the portfolio, so to speak, to push that forward. And then in line with the portfolio approach, we actually found that the Navy has established some strategic objectives in its unmanned campaign framework, which is on the internet. We really, we thought the goals in the the strategic objectives in the unmanned campaign plan framework were quite good. And it had a number of things ranging from, you know, advocating for the digital infrastructure, for example, getting capability to the fleet, commercial and taking advantage of commercial innovations, which we think is a crucial piece, which we could talk more about later. But a key part of this whole effort is to find militarily useful commercial innovations that the Navy can adapt quickly. But without metrics to measure any of that, it's going to be hard for the Navy to get into a cycle where they put out goals, push the goals down to the people doing the work, assess their progress against the goals, and then, you know, sort of do that all again until they reach them. And then lastly, we looked at prototype planning. We noticed in particular that the Navy did not have criteria by which a criteria of success. So how will the Navy know when it's time to switch from prototyping to full-blown acquisition? Because they're, as we mentioned, they're going to prototype first, toe in the water, and then try to switch to full-blown acquisitions. But that moment, that criteria isn't there right now. And that's a key piece, because that's not only what you're working, all your prototype planning should be working toward that point so that you make a good transition at the appropriate time and with the appropriate risk levels. And so that's a key piece. And then also, I think it also ties into what technology do we need to achieve to be militarily useful? And that's a critical piece for this transition criteria to be there, to establish it, and to have it kind of anchor the prototype planning, and also when the acquisition piece kicks in. We also we're hoping to see more of an integrated schedule, not a full-blown, acquisition schedule that, we typically advocate for, but even at a higher level, just the idea that as a combined effort, there are certainly overlaps between MUSV and LUSV and XLUUV and LDUUV, which was not in this year's budget, but I understand is going to make a comeback at some point. But also across all four. And so the key piece being, if I'm doing a prototype, if I'm prototyping, and if I got one of these programs in the water, how am I sequencing that with my knowledge that I'm gaining with other products and other projects that are coming down the line? And in that vein, am I developing a schedule where I have different milestones so that I'm achieving knowledge in a sequential manner, and I'm not doing things more than once, and but I'm also not going to create gaps as well. And so I think that's a key piece to solve is am I sequencing these prototypes in a way that allows me to get the most out of my prototyping, but also, conserve budget as much as possible. And then lastly, we didn't see the milestones in the prototyping planning that you'd want to see to achieve the objective. So what are the top level requirements? How do we back those down into milestones to achieve the top level requirements? And then get that into the prototyping planning in such a way that, okay, here's when, it's going to take we think 2 months of effort to get to this milestone, and then proceed across to the different milestones as the Navy makes its way toward the top level requirements and ideally the transition criteria. Same with certification. Obviously, these assets, some certifications may be the same or slightly altered, but the Navy's definitely going to need some new certifications. And so how is the Navy progressing towards those certifications? And, not only developing the certifications themselves, developing the processes to achieve those certifications, but then also backing that into the prototyping planning so that, okay, here's how we're progressing the asset to eventually meet those certifications. And so lastly, we made 7 recommendations to the Navy that are in line with everything that I've discussed. So simply that the Navy should develop a full understanding of costs, pursue portfolio approach, create metrics, develop transition criteria, schedule, and all of those things. So with that, I will pass it off to Ray.
Thanks, Larry. Excellent.
Great, Larry. Yes, thank you very much. Neat. Okay. Some of this here ties into it as well. Let me look at this 1 second here. Share the screen. All right, good morning, everybody. I'm very pleased to talk about our research here we've been doing for a few years on systems and cost effectiveness modeling of product lines, system product lines. And this is our first, deep dive, so to speak, on UUVs. Previously, myself and Mike Green, and did I see him online here today? We've been working on Navy combat systems of different types of application domains. Now we're looking at unmanned systems. And so this is our report here on a UUV set of systems and missions to address. So we use MBSC methods, model-based system engineering, things such as systems modeling language, SysML, different types of perspectives on the system and model those quantitatively, and tie these into parametric cost models where we have some quantifiable inputs that we draw from these other system models. And these are used, populate the cost models. And we look at the trade-offs here of investment cost and relative reuse cost for different portions of the systems. So this is how this framework works. Constructive product line investment model, where we, decompose the system, and some of those parts of the system or the entire system can be developed new for the first time from scratch, right? Just considering a single system, or you can alternatively choose to have a reuse. Maybe you can take some components from a previous system and modify them a little bit, or maybe they are black box reuse and even cheaper still to reuse. And so these cost models then adjust for these types of reuse and weight the effective inputs, the size inputs accordingly. So we look at the equivalent size and look at the relative investment and reuse cost. Okay, so what we did here, this is highlighting a capstone project that we recently completed. The students did a very fine job of parsing out these defined missions here for the Navy. And what we saw was, bottom line, we have across these missions collectively, that is not looking at single systems at all or single missions, as a product line, an ROI, if we use a product line approach, of nearly 500% across these defined missions. We'll be more precise, the ROI was 4.98, so almost an even 5. Okay, let me put the source document that we used for this in the chat here. So you're probably familiar with this. Where did the chat go? Okay, well, anyway, it's this one here, 2004 UUV Master Plan. Here's the URL for that, the Chief of Naval Operations. So these are the defined missions that we need across the Navy: ISR, mine countermeasures, ASW, inspection identification, and you can see the rest. So these are defined in the master plan. And this shows notionally here this use case diagram of the different functional scenarios that are common. And for each type of mission or UUV, they use a subset of these different use cases, right? And they're tailored, modified somehow, some variation across these use cases. So this shows notionally these different types of UUVs might have to do some of these, and some are not relevant depending on the type of mission, right? And so the idea is that we develop a product line architecture that is generalized for these types of functional scenarios. Think of these as functional scenarios, yet also allow variation across the missions. So here's some of the bottom line questions here. If we use a product line approach, rather than considering single systems at a time, a stovepipe approach, what is the overall ROI that it can accumulate for the types of UUVs that we need to develop? Is it worthwhile to spend the extra effort and make a generalized product line architecture? Maybe it's too costly. Well, it depends on how many systems we are going to develop, right? So, and if you think more and more locally for a particular type of specific need for UUVs, what is the reuse savings if you can leverage from an existing product line architecture? After the investment has been put on, now you can have some free components, right? Or relatively free, that you can just don't have to redesign and put them in your new system. And then given that, we've quantified the amount of functionality, what is the overall scope for the resultant system being developed, and how much time do we need, how much effort will it take, and what are the best ways to architect something to be reusable and make adaptable components so that you can look forward, anticipate changes and variations across different missions. All right, here are the central results here. Yes, there's a pack here with some detail here. So here are the different defined missions. The very first one on the left here is ISR. And why is that? Because this is our investment mission or system type, whereby after the students parse through all the different requirements that these missions have to do, this had most common ground across all the others. And so therefore, this is the basically where we put in the investment here. And these two columns represent what's called equivalent size. This basically represents how much work needs to be developed to create these new UVs. So in this case here, we're making it a more generalizable architecture for the others to take advantage of. And so the reuse size here, which means it costs more effort than to a non-reuse size. This means if you would do it as a single system only. So therefore, it's approximately 40% extra effort or cost. And so the ROI that's accumulating here across the missions is negative at that point. We put in the investment. Next up here, now we are now going to take that system architecture and modify it for mine countermeasures. We enumerate how many of the requirements can be used as is, how many need to be modified, how many are new or deleted. And so we are quantifying, from those descriptions here, we have some activity models and requirements models. We quantified the number of requirements and interfaces from these system models, and also accounted for relative complexity as well. And that's all wrapped up here, accounted for in the equivalent sizes. So long story short here, all the subsequent UVs you want to develop, we save money in these relative proportions here. This one here is just about equal. I guess that means in this case here, it needed more unique functionality, less, relatively speaking, that can be reused. And then across all of them, cumulatively, we get a 4.98 ROI. So a lot of work can be saved in the long run if you account for these variations across the subsequent missions. So given that this economic analysis shows that definitely a high ROI, well then this shows that with the same data that we have in our system models, now we can quantify how much effort and schedule time to implement these, assuming that this is a prioritization of the needs over time. And also we have a Raleigh curve implementation and presumed overlap of these increments, and just shows how long we can do this according to this parametric cost model for SysMo for estimating systems engineering effort and schedule that can also be extrapolated to full life cycle costs using the parametric cost model. So basic conclusions. This is one in an ongoing set of research projects we've done. It shows, once again, there's a high ROI if you come up with a product line approach of an architecture that can be generalized and modified in relative components. What I didn't say here, let me go back quickly here, is that the way we quantify these different pieces are different reuse categories. For example, are they new, designed for reuse, modified, deleted, or can be used as black box reuse? Okay. So this Coplimo model we've been using for different types of systems shows that it's very useful here to look at the trade space here on what are the relative investment costs and ROI with respect to product line decisions. And this one showed a very strong ROI of about 500%. And if we're going to do this the right way to be optimal, we want to consider the full set of potential systems rather than a single system from day one, early stage of design, look forward to these variations rather than later on in acquisition, try to shoehorn in a product line approach when it's not so cost effective and everything has to be redone and refactored. And that is our summary there. Okay, with that, I guess next in turn, Captain Christian Thiessen, and I'll give it over to you.
All right, thanks, Ray. Do you mind unsharing your screen?
Well done, Ray, thanks. And transitions are going wonderfully. Well done.
All right. Hello, everyone. My name is Captain Christian Thiessen. I am an infantry officer in the Marine Corps. And along with my two advisors, Dr. Britta Hale and Dr. Douglas Van Bossuyt, we're here today to talk to you about reducing asymmetry and countering unmanned aircraft systems. I'm currently seeking a dual master's degree in information warfare and applied design to innovation. So to begin, here we have two pictures taken about 30 seconds apart from one another, and they are a before and after of a drone strike on a convoy of Russian surface-to-air missiles. This drone strike was carried out by one single Ukrainian TB2 that can be purchased for about $1 million from Bayraktar Industries based out of Turkey. And the destruction criteria here is they destroyed over $50 million of Russian surface-to-air missile equipment, which is the exact equipment that was supposed to protect their ground troops in the first place. So why does this matter and why should you care? Well, the bottom line is that the current short-range air defense systems are insufficient in their ability to counter the threat posed by uncrewed aircraft. And why is that? We believe and we assert that this is due to the fact that there is yet to be a serious incursion or attack by UAS on American soil. And because of this, the Department of Defense and Department of Homeland Security have largely focused their efforts on terrestrial counter-UAS technologies that have minimal mobility and limited effectiveness at altitude. So the solution that we propose is aerial interdiction using non-kinetic cyber and electronic attack devices that are attached to friendly UASs for an aerial counter-UAS security patrol. So some background and motivation, starting from the top left and moving around the screen to the bottom left, we can see an evolution in UASs over the past decade. So in the top left, in 2014, ISIS began using commercial UASs to record coalition troop movements in Raqqa, Syria, as they moved rapidly to take away the advantages that coalition forces had there. Then in Mosul in 2017, ISIS outfitted their UASs with explosives to create a rudimentary air force capable of close air support. And while the ISIS drone program didn't ultimately have a long-standing impact on Operation Inherent Resolve, this taught valuable lessons to the world on how weak non-state actors can leverage emerging commercial technology to gain an asymmetric battlefield advantage. Next, in the 2020 Nagorno-Karabakh conflict, the Azeris, the Azerbaijan fought Armenia, and the Azeris deployed a more comprehensive approach to training and equipping their forces with unmanned systems. By integrating the TB2 into their air force, they were able to get close and deep air support capabilities on the cheap, which ultimately resulted in the destruction of over 350 Armenian armored vehicles. And then finally, back to the original, the first slide here, the current Russo-Ukraine war has proven how UASs can be leveraged to have an outsized impact on a modern battlefield, especially when a weaker state actor like Ukraine can leverage these very cheap technologies to destroy or counter the advantages that one of the most powerful militaries in the world has. So what are our current counter-UAS systems? Our current approach is from a 2019 study by the Bard College Center for the Study of the Drone. Over 537 systems were profiled. They ranged from static ground-based sites like Kaki's Korean Sky Tracker, that's right here. And that's currently located in Bangor, Washington at Naval Submarine Base Kitsap Bangor. And then Anduril Industries Sentry Tower right here that is currently deployed down along the US-Mexico border. On the other hand, the Marine Corps has established a ground-based air defense program office that is invested heavily in the MADA system right here. And in 2019, this saw operational success in the Straits of Hormuz shooting down an Iranian drone. These systems are generally are considered general purpose electronic warfare or electronic attack tools. And the Madachy in particular also has a Stinger missile capability to shoot down larger aircraft. And then in the marginally effective category are the nets, the battering ram drones, the handheld electronic warfare systems, and shotguns. So here we have the Anduril Industries Anvil. That's a battering ram drone. We have the net here, and then we have D-Drone's handheld system that looks similar to a rifle. And ultimately, what this study showed us is that the most effective systems lack mobility and the most mobile systems lack effectiveness. This report also shows us that there has been no true attempt to use air-to-air interdiction to deliver a cyber attack as a mitigation measure against UASs. So what's a better strategy? This brings us to the idea of defending in depth. The Marine Corps teaches its infantry officers to use the defense in depth concept to allow friendly forces to recover and regain operational initiative by denying an enemy's access to vital areas or by eroding an enemy's ability to concentrate firepower in an attack. And one of the most important tenets of the defensive depth is to use your most effective weapon system only when you have to. And in other words, in the terms of counter-UAS, don't begin an engagement with your static ground-based air defense systems like the Khaki Corian or Anduril Sentry Tower. However, our current technologies do not support this mobility, and they are in line with a more medieval thought process of defending forts and castles with a static defense line. What you can see here in an example is a cutout of a naval submarine-based KidSat Banger and a mock-up of what their perimeter could look like to use this defense in depth concept. And the thing that really allows for success in the defense in depth is the use of security patrols to interdict the enemy in piecemeal fashion. So to fix this, we believe that the Department of Defense and the Department of Homeland Security should use a layered approach to defense using aerial interdiction patrols to disrupt the incursion of adversarial UASs on critical infrastructure and on military installations. This causes the adversary to commit their forces in piecemeal fashion and would deter an adversary from being able to attack on their terms. So from a technological standpoint, a solution that we have developed is called the Detachable Drone Hijacker. It's a modular, low size, weight, and power device that is designed to deliver a cyber attack against adversarial UASs. This device can be easily attached to another Group 1 or Group 2 UAS to extend the range and capability of our short-range air defense system. And it can be adapted to fit on these other UASs without any detrimental effects to the hosted device. Additionally, the Detachable Drone Hijacker can be easily networked with current systems like the Corian and Khaki's Corian Sky Tracker and Anduril Sentry Tower, and can augment and enhance their capabilities rather than replace it. So after some initial testing and results, we tested our first prototype in a variety of environments, both ground and air, to determine not only the effectiveness, but the power output and thermal characteristics associated with its use. This is critical when we are considering integrating this type of equipment on other aircraft. So our initial prototype operated solely off of its own power source. It weighed only 400 grams and it cost about $250. Right now, in its current state, it works against Wi-Fi drones, and we're going to expand this research to incorporate other modulation techniques that are used by DJI and the do-it-yourself drone community. And since those late February and early March test results, we have improved the design and have drastically improved the effective range. Those results came in from experiments last week and are still being compiled, so we're not able to fully present them here, but they are very promising, and we have some great integration with some other programs that are here at MPS. So this gets us to the cost effectiveness model. And as we can see here, as we go from left to right across this continuum and from bottom to top. So left to right, we have the effectiveness continuum, and bottom to top, we have low cost to expensive. The detachable drone hijacker fits neatly between this low cost, but moderately effective in its current state, to where we can expand this capability and this idea, this concept of aerial interdiction using using cyber attacks, to really push up into the maximum effectiveness, but still at a very low cost. And so what we see here is it's extremely low cost in comparison to its competitors. By not having to overcome the physical limitations or path losses associated with ground use, like the D-Drone Drone Defender, that was the handheld electronic warfare system, as well as the Andril or Khaki, or the Mattis, which is run by Sierra Nevada Corporation and Lockheed Martin. We can extend our max effective range, and it actually is much more effective than kinetic effectors like nets and shotguns. And so while our current prototype is not as effective as these general purpose electronic warfare systems, it only costs $250, and that's in comparison to the $150 million contract that was delivered for the Mattis program of record to Sierra Nevada and Lockheed Martin. So with that being said, I thank you for your time, and I look forward to the panel. Paul, over to you.
I can do that for $250.
Okay, Christian, thank you very much. So I'm going to see how to navigate open questions. It looks like one got asked over the net, asked and answered. So I'm going to phone a friend and see if others can just go off mute and ask me or the panel members questions about their papers. Nadia, I see we're instructed to use the Q&A. I just not seeing any questions pop up. So if people want to just unmute and ask a question with their hand raised, we can do that too. Standing by for see how this works. Ready, go. Let's see if I see. Please use the Q&A button. So Ray, I see where the model-based system engineer models for the different variants of the product line, and your answer, I don't know that it went to everybody, says the students created the model-based system engineer models for the UUV types. So students made them over. See if more questions are coming up. Okay, while I'm gonna play dealer's choice, and I'm gonna ask, hey Larry, are you still on the net? I don't see you, but I'm trust you're out there. There's Larry. So Larry, did you do any work in your study of unmanned systems to examine our land-based test sites, our cloud computing or digital ecosystem infrastructure? You refer to that we need that. Did you study any of the digital infrastructure that we have already leveraged? Question mark.
Yes, we got to look into a little bit of that. As you may know or may not know, we have another mandate to actually look in depth at the digital infrastructure. So we are very much looking forward to soon, hopefully, beginning some more work that takes a much deeper dive into the digital infrastructure, and some folks are pretty excited to show us what's going on. So we're excited to learn about it. So it'll be a lot of fun, I think. So we didn't get into it as much as I would hope, just because we had to keep our scopes appropriate. But yeah, we're about to dive in, so we're excited.
Thank you. I'm going to go back to the Q&A and see I got some more questions. Okay. see who this one's from Alfred Schenker. Did sustainment governance considerations enter into the return on investment calculations for the product line? And I'm assuming that one is to Ray. Again, did sustainment / governance considerations enter into the ROI calculations for the product line? Ray, over to you.
Sustainment is not considered in our costing in this exercise, no. Governance, just as much as it would be for, say, systems engineering work in a standard acquisition project. However, though, if you want to consider those other aspects, the results are probably, in a relative sense, still valid if you want to consider the full life cycle. And that's actually where we want to take our research now, is more into sustainment. That's a very, very good and relevant question.
Learning the mute button again. So from Mr. Ortiz, will the United States Navy pursue data rights or intellectual property needed to repair and maintain these systems with their own sailors? And he elaborates, hey, Navy, this may be expensive, but may be worth the investment during operations and sustainment phase for the fleet, who can actually perform the repair, maintain themselves at the O level, organization level, rather than await contractor support. I would steer that to each of the panel members. Over.
Well, I could jump in. I have a lot of opinions about data rights. My work before the Uncrewed systems was actually specifically on sustainment planning during the acquisition process. And we took a pretty big look at intellectual property and data rights. And yes, I do in general think that, one, the Navy needs to do more in terms of not just accepting government purpose rights, but really take a hard look at what data rights are necessary for the specific product, whatever it is, biggest from a ship all the way down to something smaller. Because I think the world has become much more complex, and I think that, and I also think that if people, certain contractors, if they're willing to get away with just giving the Navy a technical manual and saying that that's government purpose rights, which was what happened. We found that happened on a lot of LCS type components.
Hey, Larry, this is call sign Pablo. Can you get your microphone closer to your mouth?
Oh, sorry. Thanks.
Yeah.
So we found. Oh, sorry. We found that that the Navy needs to do more to assess data rights and understand what data rights are worth the price for specific products, and cannot settle anymore for government purpose data rights because it's too complex and it varies too much between components. And we found some components on the LCS, for example, that were simply just like a technical manual you'd get for your dishwasher, and that was the government purpose rights. And so more needs to be done on that fact. And I think with the uncrewed systems in particular, I think the biggest thing is actually looking at the technical data rights around the algorithm components, and the autonomy components is going to be extremely important, because if the Navy can't develop and push algorithms at the speed of warfare to its vehicles because of technical data rights, for example, that could be a significant problem.
Yeah, thank you for that adjustment on the microphone. I'll read you Lima Charlie. And I guess I'll just ask, does Ray and or Captain Christian Thiessen want to offer any part of that one? Or I can go to the next one. Over to you, either one. Okay, so I'm getting a shaking the head no, which I'm a great body language reader. So that works great on the video. Hey, I'm going to just chime in from ASN RDA. So I sit in and amongst the service acquisition executives. And to Larry's point, this is kind of a tricky challenge. I would tell you, we don't want to buy anything that our operators are going to depend on that doesn't have the tools they need to actually support it operationally. ladies and gentlemen of the jury, we're going to be fighting in contested environments, and we just don't have the means to go float around and be dependent on others when we need to make the stuff work, operate it, and repair it. And I'll just offer and say, at some point, we're going to get pretty darn good at delivering software like commercial companies do, where we can update algorithms and get them to the people who need it automatically. And that's a dream, and it sounds like really great, but we actually have cases where we've been doing it. So I'm going to declare victory on that one for the moment. And then I'm going to switch over because, yeah, Larry, we took the microphone from you for just a minute. GAO, Team GAO. Billy Carver. Hey, there have been a lot of lessons in the Air Force unmanned aerial platforms, including vendor lock lessons. Is the Navy incorporating the lessons into its unmanned planning? I'm going to go first, and then I'm going to ask any of the panel members if they want to add. I have the high privilege of briefing the Undersecretary of the Air Force either Friday or Monday, and the Undersecretary of the Navy. The bottom line is I had served in OSD when it was Dyke Wetherington running the unmanned portfolio when we had the first Iraq and Afghanistan wars. The bottom line is I think the synergy across our services is going to happen, but like anything, we come together when we're desperate, and then we go our separate ways, and then we come together. I'm actually on a S&T panel tomorrow on C-SPAN, 1630 Pacific Daylight Time, if you care. And I'll be with Secretary Heidi Shue and Kristen Baldwin of the Air Force. And I would tell you, there's a lot of service synergy on this particular round of technology. We have our NAVAIR brethren, the NAVAIR Syscom and the PEOs out at Pax River that are developing systems like Stingray and Triton. And so on this smaller attritable unmanned, I think synergy is going to be important. So the policy of the United States Navy is we want to share lessons learned and learn from them. It's easy to say, harder to do. And that's my 2 cents on that one for Billy Carver. Did Larry or Ray or Captain Thiessen want to rebut or embellish my profound statement of collaboration with Air Force? Question mark? Perfect. I'm getting shaking heads on that. Okay, so now I have, let's see, I'm going to declare answer live. That one's done. And I saw somebody else come up on the net. Who is this next one? Ooh, David Lewis. Oh my goodness gracious. I wonder if that's Vice Admiral David Lewis. Portfolio management is missing from the DWIA program management training requirements. A recent NPS student thesis did a side-by-side between the program management and PMI, PMP certifications, and portfolio management was the principal difference. A significant or big gap applies to unmanned management and software development also. Any chance the Navy could change that? 100% yes. Not only can we, but I think that's what our unmanned task force is literally trying to do. And so when I say we're trying to do it, we aren't changing the curriculum yet. So we haven't trickled it down into the curriculum. But for Mr. Lewis, Vice Admiral Lewis, it seems fundamental that if we're going to deliver the capabilities to the United States going forward, unless and until we start thinking across these capabilities in a portfolio fashion, we're going to miss massive opportunities. And the portfolios need to expand to include the other services and the Defense Department and industry. So I would be a strong advocate. It turns out I'm not the PM national lead, but I'm the engineering lead. And I can take this direct question, which I will, into our Marianne Lyons and see if we can't start provoking and build a timeline to get portfolio management as part of the requirement. So that's my 2 cents. Because I'm in the Pentagon and I work for the Navy, I can take that action. So did anybody on the panel have an opinion about portfolio? Basically portfolio coordination, portfolio reviews. We tend to put all of our money on individual programs, and we act like they're the only thing that matter, when in fact at the operational level, the national level, we kind of need enterprise capability, and we tend to be penny wise and pound foolish in the portfolio, mostly because we never analyze it as a portfolio. Final 2 cents is I do believe OpNav is thinking along those lines as well, not only in portfolios, but aligning across capabilities. So Admiral Lewis, that's my 2 cents on that one. Anybody want to chime in? I'll pause. They're going to
Sure.
go after you guys for just a minute. Larry, over to you.
Sure. Yeah, I just wanted to add what I think is the most important piece of portfolio management, which I think obviously it should be a part of the DWIA requirements. I mean, that would be great. But that is too, I think portfolio management gets the bad rap that it doesn't allow for innovation. And I think the exact opposite is true. I think if you have a proper portfolio approach, it allows you to justify taking 5%, 6%, 7%, whatever you adjust, depending on your portfolio and everything else, but taking a percentage and trying to shoot the moon, and balancing that against other approaches and other advances like we talked about earlier today. So I think that's a critical piece of the portfolio management, is that it can, I believe if done properly, it could spur innovation.
Yeah, and I'm going to offer that, and all of you have experienced in different forms in your life, but sometimes I don't know what they're called, cylinders of excellence, silos of excellence, where we get tunnel vision on requirements, budgets, and schedules and costs around a specific thing, and so this whole plethora of acquisition professionals seem to be focused on themselves as the center of the universe, when if they look to the left and the right, there's benefits. It's harder sometimes, and it requires some humanity and some social skills that quite frankly are missing at times, unfortunately. But we need to incentivize leaders, and quite frankly, I'm counting on the PEOs also to drive some of that leadership across their own portfolios. I'm sad to report, in some cases, we're wanting there as well. But I think it's really good, a great question, and I believe it's aspirational that's what we need to do. So let me go back and see. I got another open question. That's not a question; it's a statement. Hey, Paul, if it's not a requirement, it won't happen. So yeah, great feedback. And that's truer than ever. We can't just aspirate people to do the right thing. We need to require it. So I'm plugged in here with our datum, our basically that runs the coordination of curriculum for the acquisition workforce. So I think I have a running head start on chasing this one. Okay, here's a new question. Let me declare that one done, even though Admiral Lewis may not agree. Let's see. Hey, we saw an ROI of almost 500% for a theoretical UUV system. How does this compare to manned systems? If the unmanned ROI is greater than the manned ROI systems, how can the Navy use this to leverage a smart transition to many more unmanned systems? Ray, I think that's going right at you.
Wow, that is a super question, Billy. We have done some other economic analysis in different domains like combat systems that are manned systems, and we've frequently got similar results where, say, on the order of about 3 systems subsequently after the baseline, you start getting a positive ROI. We don't have enough data to generalize manned versus unmanned. I guess we could hypothesize maybe unmanned might be more economical in the long run, but we'd like to get some quantitative data to see. I would really like to answer that myself. It depends, I'm sure, on the type of systems we're talking about, environment, and all the context, the requirements, but presume, I know we've seen very large ROI for both. Hope that helps a little bit, saying that's a very good research question to go forward with.
Yeah, and the only thing I'll add is on our campaign of learning, you know, it's with all the UUVs that we're experimenting with, at some point we're starting to get some facts back. And so God bless the research and the theoretical, but we need to inform the theoretical with what we're actually experiencing presently. So that closing that loop with all the experimentation we're doing will be essential. Okay, let me hit done on that one. And let me go to open. There's no more open questions. And we got 9 more minutes. Actually, 14 more minutes. Come on, 37 participants. You can't possibly be done. Your curiosity is just percolating.
I had a question for Larry and Diana on their research.
Go for it.
You both stated that uncrewed maritime vessels weren't included in the battle force inventory. Is that also due to tonnage restrictions that have been established in the past, or is that something completely different?
Good question, Captain. My understanding is that right now, I think it's more of a, to tell you the truth, I don't really understand a lot of the distinctions that are drawn between those and the shipbuilding plan. Even though I've looked at the shipbuilding plan in a lot of different cases and carried it, because it's sort of a, from our perspective, it's not a U.S. code distinction. It's a distinction that the Navy makes within sort of the parameters of the U.S. code that governs the shipbuilding plan, if that makes any sense. So from our perspective, in some ways, if it was a part of the battle force inventory, that would lever a different, reporting requirements on it. For example, requiring sustainment cost and requiring things like that. So I know that there's probably a hesitation to push it that far, especially this early on, given that there isn't proving combat capability yet, would be, probably where I would guess, but I'm just guessing, admittedly.
Okay, I'm gonna jump in on behalf of Mr. John Camp. Hello, John Camp. Let me be a heretic for a moment. I love that opening sentence. I'm gonna use that again. One take on the panel discussion might be to ask the question of the preference for uncrewed systems as the front line instead of manned systems. And for interpret, he added right below it, when is it preferable to go uncrewed based on research to date? That's a great question. I'm going to chime in with an initial impression, and then I will back up and let others on the panel offer their feedback. Ladies and gentlemen, the threat we're up against is growing more capable and more lethal. And we really would prefer to lose gear than we would prefer to lose humans. And so, I can't speak for the Secretary of Defense because I'm sure there's long-standing doctrine and culture on what we need to verify when we're actually in the weapons zone. But the bottom line is anything we can do to de-risk humans being vulnerable to attack at the same time performing the mission that we need to accomplish, in my mind, that's a win-win, and we need to push that. I'm personally aware of some of the systems and CONOPs that we're thinking about that absolutely favor the uncrewed as being the leading edge. In fact, more so than I can describe on this net. So I think where that gets different in some circles is from the, we talk about artificial intelligence and machine learning and what decisions are being made at the Uncrewed platform. I think we've got a lot of learning to grow trust and confidence that what we are sending these devices out to do, they do and do well, and that they don't jeopardize things that we don't want. But I got to tell you, I think this isn't heretical. This is not orthogonal at all to what we're actually thinking about, because by the time we look at how far we have to be away to protect ourselves, the only thing we can put forward to do the mission in some cases is uncrewed. So I think that's where we're going, and that's undersea UUVs, on the surface USVs, in the air UAVs, and to the extent we fly things in outer space, yeah, that too. That's my view. Does anybody on the panel have an additional perspective? Over.
Yeah, I think just to reinforce what you have stated there, Paul, is the biggest issue that I think people are going to have as ground users is going to be trusting the system to do what it actually intends to do. And there's a lot of research going on at MPS right now on that human machine trust. But like as an end user, there's a lot of times where I've had a piece of equipment that was supposed to do something that the engineers described it to do, and it didn't do that thing properly, or it was too complicated or complex to really figure out and utilize properly. And so a lot of times that ends up with throwing it in the corner, and then we get back to the humans first instead of equipment first. So that trust aspect is huge. And that's really where I think that we really need to deeply think and work in that field, is how is this interfacing with humans and the organizational structures that we have, not just from a con-op on paper, but also practical implementation. Over.
Yeah, copy. And I'll come back and I'll try to link this to something that Larry talked about, although I need to meet Larry in much greater detail on what we're doing now and what we could be doing in the future. I will tell you the reason we're trying to build the modeling and simulation and digital ecosystem infrastructure is to do algorithm development for sure, but it's also to do a lot of sets and reps, like not tens and not hundreds, but thousands and millions of runs over the computer at the speed of machines, so we can really learn the nuances of all of this. And quite frankly, it's going to be a long journey. So if we end up spending $1 billion or more, I don't know what the right billions would be. To me, that's foundational, and quite frankly, is a drop in the bucket to the capability we could have. So that building that trust is going to be important. I will tell you on, and I can't say it on the OpenNet, but when we have exploited computers and AI, ML algorithms, and really put the computing power on the systems that we need, it is amazing just how capable these systems and how smart they are. And it's just going to take us time to grow leaders that have operated with it, have experimented with it, have experience with it, so that they're more confident when they're called on in operations. On a positive note, we better hurry the heck up, because we don't have decades to do this. We're kind of on the pivot right now, and we better put a hell of a lot of attention on this particular topic. It's why Vice Admiral Khan in N9, the VCNO, Vice Admiral Cooper in 5th Fleet, the Marine Corps, we're going heavy on experimentation so we can start getting ourselves comfortable with a completely new way of doing business. I know we're kind of in the Navy, we're quite attracted to the carrier strike group model. We've been doing it for a long time, and we got good at it, and that's what our comfort zone. Well, now we've got distributed maritime operations where everything is changing at a fairly significant pace. And quite frankly, having some forward deployed uncrewed systems to take on some of that load and danger is exactly what the United States needs. I'm looking at the clock. I'm tracking 15 here, 12:15. I'm going to see if there's one more question. It looks like there is. I'm going to open it up. And then I'm going to wrap it up so that we're done right on time, because I'm told we get points for being timely and chronological. Mr. Mann, absolutely agree with your AIML observations. Totally game-changing, has been very useful in my organization to change how we engineer, design, protect our systems and the IP, and ultimately communicate with the warfighters or provide them with pertinent information. So I appreciate that acknowledgement. I will tell you, our experience is not penetrated far enough and wide enough across the system developers, but that is starting to change. It just turns out we're spending a lot of time using the systems that, quite frankly, we built either decades ago or 10 years ago or 5 years ago, and we're trying to leverage technology that's being delivered today. So I'm going to tie it up there. I'm very proud to have served with Larri, Ray, and Christian. You guys did an excellent job of your research. It's been a high honor to serve as part of your team. I can tell you that unmanned systems, uncrewed systems, unmanned, and partnered with uncrewed systems, it's got the CNO, the VCNO, and quite frankly, the senior leaders in the department really focused on new ideas, affordable, attritable lethality that, quite frankly, might be just what the doctor ordered. We can't go toe-to-toe with the budgets on the way Chinese is producing ships and capabilities. We're going to have to find our advantage a different way. Uncrewed systems is one of the ways the United States is going after it. And we need all of you on our team. Continue the research, continue the work, and let us all follow through on the mission. And quite frankly, the whole goal in all of this, by the way, is deter the hell out of it. We don't want anybody to even mess with us, for them to be so confused, so concerned about the fact that we're going to destroy them that they just never mess with us. That's actually the plan. Okay, so I'm tracking. Pause there for any final. We got 2 minutes. I got, let's see. Oh, there's 2 more. Let me hit done there. Let me enter that live. And I'm getting a scorecard of 0 open question, 10 answered, none dismissed. Sounds like we had a timely review. Congratulations to everyone. Have a great rest of your acquisition research. Being affiliated with Naval Postgraduate School is core to the United States security. So out here, unless otherwise directed.